Hey everyone, this will be part one of the video that goes over the event problems of the review for exam 12. Okay, so as usual, I'm gonna do the events and I'm gonna let you guys do the problems. So I'm going to start with number 2. So for number 2, I'm going to simplify 27 as 9 times 3 and 9 is 3 times 3. So then we have the prime factors of 27 are 3 times 3 times 3. Since we have 3 3's, we can take out a 3, right? So then we have, let's see, 2 times the 3 that comes out, and then this 3 stays inside. And for this one, I'm just going to leave it as it is because I can't take anything out. And this one here, this is 4 times 3, and 4 is 2 times 2. So then we can take out a 2. So minus 2 square root of 3. But then 2 times 3 gives us a 6. So this is 6 times the square root of 3 plus 4 square root of 3 minus 2 square root of 3. Since they all have the same radicand inside of the radical, then we can just combine them because they're like terms. So we have 6 plus 4, which is 10, minus 2. That gives us 8. So then this is 8 square root of 3. And that's the answer to number 2. Okay, number 4. For this one, again, I'm going to simplify. This is 4 times 3, and this is 2 times 2, which we just did on the previous problem, number 2. So then I'm going to change this to, so then this is 6c over, we have a 2 coming out, and square root of 3c. So then 2 goes into 6 3 times, so then this becomes 3c. Right? So then I'm going to rewrite this as 3c over square root of 3c. And let's rationalize by multiplying by the square root of 3c, numerator and denominator. So then numerator becomes 3c times the square root of 3c. But watch what happens to the denominator. The square root cancels, so we have 3c. And as you can tell, 3 over 3 reduces, c over c reduces, so then all that's left is the square root of 3c. And that's the answer to that problem. Okay, so that's number 4. Let's go on to number 6. So number 6 has to do with conjugates. Since this is 2 minus the root of 7, then we need to multiply by 2 plus root of 7. And we do it to both numerator and denominator. So then I'm going to multiply here. 5 times 2 gives me a 10, and 5 times the square root of 7 is 5 square root of 7. And then denominator, 2 times 2. Okay, so this is 2 times 2, that's 4. 2 times the square root of 7, that's plus 2 square root of 7. And negative square root of 7 times 2, that's negative 2 square root of 7. Okay, and negative square root of 7 times positive square root of 7, the radicals cancel, so then we just have negative 7 left. As you know, these two cancel. So then what we have left is, let's see, 10 plus 5 square root of 7 over 4 minus 7, that's negative 3. Okay, so then this cannot be simplified. So all we can do is make the whole thing negative. So that means negative 10 minus 5 square root of 7 over 3. So all I did was, since this 3 is negative, then 10 and the whole thing becomes negative, or change the sign. So that's the answer to number 6. All right, let's go to number 8. And for number 8, we have another one of those. Okay, this is 2 minus the square root of 3. So then the conjugate is 2 plus the square root of 3. So we can rationalize the denominator. Again, don't forget in Algebra 2, the rule is you can't have radicals in the denominator. Once you get to more advanced courses, then it's possible that your professor might say, that's okay if you leave it, if you leave the radical in the denominator. But for this course, we don't. So 5 times 2, that gives you a 10. 5 times square root of 3, that's plus 5 square root of 3. And then let's see, square root of 3 times 2, that's plus 2 square root of 3. And then the square root of 3 times the square root of 3, that's just the 3 because the radicals cancel. Okay, now denominator, 2 times 2 is 4. 2 times square root of 3, that's plus 2 square root of 3. Negative square root of 3 times 2, that's negative 2 square root of 3. And I hope you can see those are going to cancel. And then last, negative times positive is negative 3 because, again, the radicals cancel. So then these two terms cancel out. And then we have 10 plus 3 on the numerator. So that becomes a 13. 5 plus 2, that's 7 square root of 3 over 4 minus 3, which is 1. So then, I mean, you can write the 1, but you don't have to. I'll just leave it, since it's over 1, I'll just leave it like this. So this is the final answer for number 8. All right, let's go on to number 10. So for number 10, this is properties of exponents, okay? So then this is equal to x to the negative 4th, because you just combined 3 minus 7, which is negative 4. So that was an easy one. And then number 12, what I need to do is I need to distribute this power. So apply the power of power rule. So then this is 2 to the 5th, and then 2 times 5, that's 10. So 10 x to the 10th power. All of this is over 3 x to the 3rd. Okay, 2 to the 5th is the same as 2 times 2 times 2 times 2, which is, I don't know if I said that correctly, but it's 2 times 2 times 2 times 2. You're multiplying 2 5 times. So this is equal to 32x to the 10th. And let me apply that property here, okay? Because we're dividing here, so that property means you subtract this 3 from that 10th. So that's the one of the properties of exponents that was covered in the lesson. So this becomes x to the 7th, and this is just 3. Now the question is, does 3 go into 32 evenly? Does it go evenly does it go evenly into 32? The answer is no, right? There is no GCF for 32 and 3. So then this is our final answer for number 12. Let's go on to number 14. So number 14, for this one, they have the same base, right? And they have the same index, which means we have the cube root of 5 to the 4th. So I'm going to make this the easiest way possible. Okay, so we have the same base. That means we have 5. This has a power of 3/2. And this one also has a power of 3/2. So we apply the product property of exponents. Okay, so 3 over 2. When you add 3 over 2 plus 3 over 2, just add the numerators. So 3 plus 3 is 6. And then 6 divided by 2 is 3. So then this is 5 to the 3rd. And 5 to the 3rd is 5 times 5 times 5, which is 125. So this concludes part 1 of this review video, and covering only the even problems. So I do the other evens on another video. Thank you for watching. Bye-bye.